We're going to begin our new unit. It's called counting. And we're going to take the fundamental counting principle, but it's going to take us a little time to get there. So let's start off with Ryan plays on a soccer team. And the soccer uniform has 4 different jerseys. So we're going to talk about 2 different decisions we need to make, or 2 different events. So you have 4 jerseys. So we are going to decide between 4 jerseys: green, black, white, and vertical stripe. So I have denoted these G, B, W, and V. And then the next thing we need to do is we need to say, we need to decide between 2 different shorts, black and white. Now, we're going to draw a tree diagram to determine the number of variations of the soccer uniform can have that a coach can choose from each game. Well, really, there's 2 decisions. And instead of trying to make both decisions at once, I'm going to make one decision first. And I'm just going to say, I'm going to draw a tree diagram of my jerseys. So, pardon me, there we are. So that's the tree diagram of my jerseys. So I've just started out with, I like to make a little dot there. There's that little dot. I'm going to say this red dot is going to represent my decision of choosing jerseys, and I have 3 jerseys options. Well, now that I have chosen my 3 jerseys, now I have 2 different shorts, black shorts and white shorts. So we're going to continue on with our tree diagram as you've done in previous years. And I'm just going to choose shorts now. Pardon me. There. So really what this represents here, it means I'm going to choose a green jersey, black shorts, green jersey, white shorts, black jersey, black shorts, black jersey, white shorts, white jersey, black shorts, white jersey, white shorts, vertical stripe jersey, my personal fave, and black shorts, vertical stripe jersey, white shorts. So we have these options available to us, and it may be helpful if we write these in pairs. So I'm just going to write these in pairs, and I'm just going to say, well, how did I get to these ends? Well, this first one, I chose a green jersey. So if you want jersey, shorts, so green jersey, black shorts, green jersey, white shorts, black jersey, black shorts, black jersey, white shorts, white jersey, black shorts. And you just continue going down, down, down each one. So for instance, this one represents vertical striped black shorts. So this bullet right over here would match up with that. What we notice is I have 8 possible variations. And if you take a look and you're like, well, how many choices did I have for jerseys? Well, I have 4 choices for jerseys, and I have 2 choices for shorts. So it does make sense that we have 8 possible different variations of our soccer uniform. Now, the soccer team recently purchased matching socks in 2 different colors, green and white. If you consider a change in sock color to be a change in uniform, how many different uniform variations are there? Well, I got lazy. Not lazy. I just copied and pasted. Thank God for technology. So now recognize that this first one represents our jerseys. These ones represents our shorts. Now I need to make other decisions, and that is socks. So here we are. There is 8 different choices I can make with jersey shorts combinations. And now if we have socks, now what's problematic with this is there's going to be so much. So I have green and white, and this is really going to explode. So green and white, green and white, green and white, ooh, yeah, it's kind of getting really smashed up in there. But how many different choices can we make? Well, let's choose a jersey. 4 jerseys, right? And then what did we do previous? Well, 4 times 2. It was 8, so I'm going to try 4 times 2, and that gives me 8 different combinations. But each one of those 8 combinations also has 2 choices within this now. So now there's 16 different possible variations now. My mistake. I use combinations, and I'm going to try to be very selective when I use the word combinations, because in English we use it all the time, but in math it means something very specific. So I'm just going to scroll up here. I'm going to say the fundamental counting principle. Wow, it's a fundamental principle? Wow, that has to be important. It says that if there are A ways to perform one task and B ways to perform another, then there are A times B ways of performing both. This can be extended to more than 2 tasks. So if there are C ways to perform a third task, then there are A times B times C ways to perform the 3 tasks. Now, here it says tasks, but I like to maybe rewrite this as decision or task. So up above, we're talking about soccer uniforms. And we had to make a decision. Jersey. Well, there are 4 jerseys. And then, while we thought about it, we have to make another decision, and this was shorts. So it's there's 2 different options for shorts, so times 2. And then when we had socks, it was times 2 again, because there's 2 different options within that decision. So let's take a look here. Example 2. A luggage lock opens with the correct 3-digit code. Each wheel rotates through the digits 0 through 9. How many different 3-digit codes are possible? So just to be clear, digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits if you include 0. So look at what I'm going to do here. I know that I have 3 decisions to make. So here's my roller on 1, so I need to select a number on that. Here's my roller for 2, I need to select a number on that. Here's my roller for 3. Simply what I do is I need to make 3 different decisions. Why, you might ask? Well, I need to move the first roller. That's going to be 1 decision. And then I'm going to move the second roller, and that's going to be a second decision or task. And then I'm going to move that third roller, which is going to be the third task. So I'm just going to ask myself, well, how many options do I have from rolling the numbers? Now, remember that each wheel has the digits 1 through 10. Well, how many choices do I have or options do I have for this first wheel? 10. Now, how many options do I have for the second wheel? Well, I have 10. How many options do I have for the third wheel? 10. How many different 3-digit codes are possible? 10 times 10 times 10, and that is 1,000. Now that should make sense because there are, if 000 to 999, those are the possible codes, and those are 1,000 different codes. Now let's switch up the question just a little bit. Suppose each digit can only be used once in the code. So digit, I'm just going to suggest that these are digits. These are what I'm talking about up here. They can only be once in the code. How many different codes are possible when repetition is not allowed? That is, you're not allowed to repeat. So again, what I'm going to do is I'm going to take a look. Well, how many decisions do I have to make? Well, I have 3 decisions. Now, if you want, we could call this the first wheel or the 100th wheel. This is the second wheel that I have to make a decision on, and the third wheel. And I really like to sort of visualize what I'm going to do with these wheels, because it'll help me with the questions when they get a little bit more difficult. So where do we start? We just start off with our first wheel. How many choices do we have for that first wheel? Well, we have 10. We have to be careful because repetition is not allowed. So I'm just going to arbitrarily take one away, 5. How many are there for the second wheel? 9 digits are left. We got rid of the 5. So now I'm just going to take any digit away, and I'm simply going to ask, well, how many options are left now? Well, we had 10. Now I crossed off 2, so there's 8. So there's 10 times 9 times 8 different codes that we can make. And if I take out my calculator, that's 720 different codes.